Okay, welcome to Unit 6, where we'll be talking about data and information. So previously, should be Unit 3 and 4, we talked about data and information in a brief. Okay, so today, we will now look at data and information in details. So if we remember very well, I said data is simply the raw facts, okay, most is unprocessed, while the information is the processed data. Okay, so how do we understand data and information concepts? Data are separate pieces of information. It has a huge formatting. Data and programs are the two broad categories into which all software is split. Remember, whatever we are discussing here is about information. How is the information going to be transmitted? How is the information going to have a meaning? Okay? So data can be found in many different formats, such as printed text or other numbers on paper, and as bits and bytes recorded in electronic memory. Data representation. In the previous unit, I said the computer is able to access or rather accept all the information in any language. Remember, the human language is something different. It's difficult for the computer to understand. So how does the computer understand that language? Okay, whether you give it Bemba, any language, okay, the computer would convert all the information into bits, which is 0 and 1. So data, therefore, is a term used to describe the symbols that are used to represent events, people, things, and ideas in the computer organization. The methods that follow can be used to represent the data. Okay? So data can be anything, including a number, a name, musical notes, or the color of an image. The way that we stored, processed, and transferred data is referred to as data representation. Digitalization. Through a process called digitization, we can turn information like pictures. Through a process called digitization, we can turn information like pictures, music, numbers, and text into digital data. These kinds of data are manipulated using electronic equipment. Binary numbers. We said for the computer to understand human language, it usually converts that information into binary digits. Okay, so digital data is represented by the binary numbers, which are bits, the ones we said 0 and 1s. It is possible to refer to binary digits as the lowest unit of information in a computer. How do we represent numbers? How do we represent numbers in the computer? So the representation that follows can be used to symbolize the number. Numerical data. We employ numerical data to store numbers so that we can execute arithmetic operations. The binary number system is used by digital devices to express numerical data. So how are these numbers being calculated? Okay, so decimals, mostly they are in base 10. Decimals are mostly in base 10, while binary are in base 2. I remember in grade 8, you learned about the decimals and binary. Okay, so decimals, 0 in base 10 will still be 0, while 0 in base 2 will also be 0. How do we calculate? 10 into 0 is 0 and without a remainder. 0 into base 2 is 20, again without a remainder. Okay, the number 1 up to 10, the number 1 up to 9, all those are in base 10. Then when we have a number 10, you find that 10 into 10 is equal to 1, remainder 0. So it will still be 10, which is 10, because we are putting this information in bits now. Then binary 2, 0 still be in binary 2, because 2 into 0 is 0 without a remainder. 1 into base 2, it will still be 1, because 2 into 1 is 0, remainder 1. So that remainder is the one that will form a binary. A number 2 will be 10, because 2 into 2 is 1, remainder 0. So you have 1 and 0. Okay. 3 will give us 11, which is 1, 1, because 2 into 3 is 1, remainder 1. Okay, so you have 11. 4, you have 100. How? Because 2 into 4 is 2, meaning 2 into 2 will have 10. But how many 2s do we have there? There are 2. That's why we're having 100. 5 in base 2 will have 101. 6 will have 110. 7, 111. 8, 1000. 9, 1001. So how it's moving is about dividing the number with that particular base number. Okay. We have the character data. The character data, these mostly are symbols, letters, and numbers that can be used to create character data, but they cannot be utilized in calculations. We can create our addresses, name, hair color, and other details using the character data. Typically, character data takes the form of text. We can describe numerous things such as our father's and mother's names with the use of the text. Okay, we have ASCII, which is a SCI code. Numbers like phone numbers and social security numbers can be encoded using ASCII code. Plain and unformatted text can be found in SCII text. This kind of the file will be saved as a text file with a name that ends in TXT. On other operating systems, these files have different names such as text document on Windows and plain text on Apple devices. We have the Unicode. The term Universal Character Encoding Standard also applies to the Unicode. So UN is coming from the universal, then code. The Unicode offers a method for displaying a single character in text files, web pages, and other types of publications. The term Universal Character Encoding Standard also applies to Unicode. The Unicode offers a method for displaying a single character in text files, web pages, and other types of publications.